Nearly 97% of the world's water is salty or otherwise undrinkable, and another 2% is locked in ice caps and glaciers. That just leaves 1% available for agricultural, manufacturing, and domestic uses. In this module, we'll take a closer look at the different sources of this 1% water that are available for everyday needs. After watching this module, you'll understand the role of water sources functional group, the first functional group of water supply system. You'll also recognize the main water source selection criteria and be able to assess the applicability, advantages, and disadvantages of different water sources. We'll have a look at all 6 sources listed in the compendium: rainwater, groundwater, spring water, surface water such as river, stream, ponds, lakes, and reservoir, as well as brackish water and seawater. Earth's water is always in movement, and water resources are constantly interacting with other aspects of environment. This illustration of water cycle shows how water evaporates from oceans, surface water, soil, and vegetation. Water vapor then condenses in the atmosphere to form clouds and precipitates back to Earth in form of rain, ice, or snow. The water compendium defines several criteria for source selection. This should always be considered when making an initial assessment of suitability of any available water source. First is water quantity. We need to assess if the yield is sufficient throughout the entire year. Can changes in water availability and water demand be estimated? Next is water quality. We need to know how is water quality affected by local activities like sanitation practices, agriculture, or the presence of any other contaminant sources locally. We need to assess the technologies that are required for abstraction and treatment, and if the required skills and technologies are available locally. We also need to know the energy required for use of the water source, for example, if pumping is needed or gravity can be used. In terms of acceptance, we have to know the legal and social rights around the water source and whether there are certain cultural preferences for water sources. And finally, we need to assess the impact of water source exploitation on population, environment, and ecosystems in its catchment. Now, let's look at each source's applicability for water supply system and advantages and disadvantages, starting with rainwater. Rainwater falls in drops from clouds to Earth's surface and can be collected from the roofs of buildings, hill slopes, or from temporary surfaces created by using cloth or plastic sheets, and can then be stored in storage tanks or reservoirs. The advantages of rainwater are that it's easily available in some areas and can complement other existing water sources. Also, in general, it's mostly of good quality if properly collected, stored, and supplied. However, the quality of collected rainwater can deteriorate, especially if the system is inadequately designed. Contamination can be introduced by deposition of air pollution, dust, and bird droppings, rooftops, or intrusion of surface runoff containing fecal contamination. For this reason, rainwater harvesting systems should always include a device that diverts the first flush of collected rainwater away from the storage tanks. Rainwater can also be slightly acidic because it interacts with carbon dioxide in the atmosphere to form carbonic acid. More acidic water can cause corrosion of metal roof catchment surface. Rainwater lacks minerals like calcium and magnesium and thus lacks a particular taste. During storage, rainwater can also develop taste and odor, which may negatively affect its acceptance as a drinking water resource. And lastly, a major disadvantage of rainwater is that the supply is limited by rainfall patterns over the year. Now, let's look at groundwater. Groundwater is fed by rainwater and also from surface waters like rivers, streams, lakes, or wetlands which infiltrate into the ground. Groundwater is stored in subsurface layers, also called aquifers, which are cracks and voids in soil, sand, and rocks. Groundwater is usually well accepted as a drinking water source, and it can be considered less vulnerable to contamination than surface waters. When water infiltrates into the soil and travels through the subsurface, it is naturally filtered, which may result in removal of microbial contaminants. Groundwater quality depends strongly on several factors like geological conditions, adequacy and type of extraction technology, depth of aquifer, and any existing protection measures. Deep aquifers are less vulnerable to contamination than shallow aquifers near their surface, which are likely to be influenced by contaminated surface water bodies, on-site sanitation systems, landfill discharges, industrial, chemicals, and other anthropogenic pollutants. The major advantage of groundwater is that it is often available close to where it is needed. However, groundwater is not free from the risk of natural contaminants such as arsenic, fluoride, manganese, and iron. And accessing it requires extraction technologies such as well and pumping system, which requires manpower and resources. Further, abstracting groundwater from a well at rates exceeding the recharge rate may decrease the level of water table. The well may eventually run dry, and this may also increase the potential for drawing contaminants or salt water into the aquifer. A spring is a groundwater naturally flowing from Earth's subsurface to the surface, formed due to pressure in an aquifer, which causes some of the water to flow out at the surface. Springs occur only under specific hydrogeological conditions. They can form in different landscapes, but locating them requires certain expertise, and the location may not be easily accessible since they are usually located on hillsides. Depending on the local geological conditions, location, catchment activities, and existing catchment protection measures, spring water is generally of good quality. Compared to other drinking water resources, tapping springs may be relatively inexpensive in terms of construction and maintenance cost, particularly if the spring is located close to consumers. Quantity of water from springs can also be susceptible to seasonal variation and water table fluctuations. And rainfall events can affect turbidity and also microbial contamination. In addition, surface runoff can introduce contamination from upstream. Surface water comprises any water sources that is present on Earth's surface and includes rivers, streams, ponds, lakes, and reservoirs. Surface waters can provide year-round sources that are mostly easily accessible. They can have multi-purpose use, with water being used for irrigation, drinking water for humans and animals, bathing, washing of clothes, small industries, and ecosystem services. The water quality of surface water sources should be considered poor in most cases. Contamination of surface water is likely through poor sanitation practices like open defecation or from discharge of raw effluent or from surface runoff from surrounding anthropogenic activities. Seasonal variation can impact water quality and quantity with increasing turbidity in the rainy season and high water loss due to evaporation in the dry season. Seawater comes from seas or oceans that has high salt content. Seawater has a salinity of about 3.5%, which means that every liter of seawater has 35 grams of dissolved salt like sodium or chloride ions. Brackish water is a mixture of seawater and freshwater, and while it has lower salt concentration than pure seawater, it still cannot be used directly for drinking purposes. Both seawater and brackish water are widely available, but to remove the high salt content from these sources, expensive and energy-intensive desalination process must be applied, including the safe disposal of brine byproducts. To sum up, water sources are the first of the 6 functional groups that make up a complete water supply system. When initially assessing the suitability of water sources, selection criteria to consider are water quality, water quantity, technology required for abstraction, energy, acceptance, and environmental and health risks. There are advantages and disadvantages of different sources that all influence their applicability in a particular setting. You can read more about water sources selection in the Water Compendium found in the course reading list.